Hello, welcome back to Proximity Math. Today I'm gonna do the 2008 AIM 2 number 15. All right, you finally see color after 10 years. Problem 15. This one was surprisingly easy, so I decided to do a video over it. Okay. Find the largest integer n satisfying these conditions. Number 1. N can be expressed as the difference of two consecutive cubes. Number 2. 2n plus 79 is a perfect square. Okay, let me list the form of these conditions. So find the largest n, and it's obviously less than 1,000 because it's an A problem. Okay, so two different cubes. You should really do this in your head. Okay, if you have k plus 1 cubed, and then minus k cubed, so k plus 1 cubed is just k cubed plus 3k squared plus 3k plus 1 by binomial theorem. If you subtract k cubed, it's 3 squared, k squared plus 3 squared, so 3k plus 1. And further, you can factor this as 3k plus 1, plus 1. Okay, and since k are k plus 1, one of them must be even. This term has a factor of 2, and then we have a 3 over here, so it must have a factor of 3, which means n squared is 1 mod 3, sorry, 1 mod 6. It's also 1 mod 2, so it's 1 mod 6. So n squared minus 1 divisible by 6. Okay. Now, on the second condition, what does it give us? 2n plus 79 is a perfect square. Also, 79 is really near 81. Sorry, 80, yeah, it's near 81. So just say, maybe you can do something like that. Okay. 2n, and you know what, I'm going to write it like n plus 1 because I noticed something. 2 times n plus 1. Sorry, n minus 1, so that it's 81 plus 81 equals x squared, not k this time. Okay, I'll make it, yeah, x squared. Okay. Because if we have this being true, then by difference of squares, take the 1 to the left side. N minus 1, n plus 1 is divisible by 6. And the same n minus 1 appears here. Okay. It might be related, I'm just saying. And so another difference of squares gives us okay. Yeah, now okay, since n minus 1, you know, if let's say n minus 1 by itself is divisible by 6, so then it's divisible by 3. This side is divisible by 3, so this side is also divisible by 3, which also means that x minus 9, if either x minus 9 or x plus 9 is divisible by 3, the other factor also is, because they're off by 18. So x plus 9 leaves the same remainder when divided by 3 as x minus 9. Therefore, this entire right side is divisible by 9, and therefore the left side is divisible by 9. But we have no clue whether n minus 1 by itself contributes that factor. Okay, so that doesn't really get us anywhere. And I'm showing you guys what would happen if you tried attempting this. So can we really get anywhere? Okay, we know n is 1 mod 6, and the second condition narrows it down further, does it? So we would have 2n equal x squared minus 79. And since n is odd, 2n would only have one factor of 2. And since 79 is since 2n is gonna have one factor of 2, meaning it's not divisible by 4 since n is odd, 79 is 3 mod 4, while 2n must be 2 mod 4. So this in total cannot be divisible by 4 either, and therefore x squared cannot be divisible by 4, and in turn x is not even, so x is odd. X is odd. Okay, maybe we can use that over here. Never mind, it has nothing to do with divisibility by 3, so that will help us. Okay, since x is odd, like under 1,000, we can have up to 31 squared. That would make up for 16 or less odd squares to test. And this is number 15. We have a lot of time. You should. So can we test the first 16 odd squares? Well, first of all, that eliminates all of them under 79 because well, how many are there? Like we have 1, 9, 25, 36, 49, 1, 9, 25, 49, and 81. N is obviously not 1 because n squared is not the difference of two consecutive cubes. Or is it? Well, it's the largest n. Actually, it's a difference of 1 cubed and 0 cubed, but we want the largest n. N could be equal to 1. Just keep that in mind. Anyway, okay. We have like 10 cubes to test. So that would give us n equals, first of all, okay, it can equal 2 121 minus 79. So 121 minus 79 would give us 42. And then 13 squared minus 79 would be 90. Then 15 squared minus 79 is equal to 225 minus 80 is 145. Is it 145? 46, okay. Sorry, the 79. Okay, and notice these are all even, meaning it's working. And 210 for 17 squared, and 19 squared minus 79 is 282. And then 21 squared minus 79, 441, okay. 380. My god. Sorry. Is it? Oh. 362. Minus 79 is 450. And finally, 625 minus 79 is 546. Sorry, that's not final. We also have I'm sorry, 729 minus 79 so 650. We have 762 That's 29 squared minus 79. And then, last but not least, 82 minus 79. 82 is the answer. Okay. So now, uh, um, let's see. Plug into the first condition. Which of these is, if we divide it by 2, which of these is 1 mod 6? This one is 72. This one is oh, it's 224. No, it's not. Is it? Well, no, it's not. Okay, 546, which is 273. It's not. 650 is 325. Okay, it is. And then 762 would be 381. That's not. 882 is 441. 441. No, it's not. Okay. We have only 4 to test. Okay. This is a difference of 1 squared, and it's actually it's a difference of 1 squared and 0 squared. This one gave us 73. So 72 are actually, 73 is n. 73 is n. So it's okay, n squared. Can n be expressed like this? We have n minus 1 times n plus 1 to simplify. So 72 minus 74, you get 24 times 74. 24 times 74 is going to be k times k plus 1. 24 times 74 is 1776. If we divide by 44, then 42, then 40, it eventually jumps up and down. Basically, there's no nearby integers which multiply to this. 362, you would actually get, okay, n is 181, so we get 180 times 182, so divide by 3, 60 times 182. You can approximate its square root as around 100 or more. So it's actually, if you divide by numbers right above 100, it's 104 times 105, which means it is actually valid. So it's 105 squared minus 104 squared. Yeah. Sorry, 181. Okay. And then 650 is 325 times 2. So 324 times 320. 325 times 2. So n is 325 and n minus 1 is 324, and then 326. Divide by 3 and then take the square root or approximate it. It's going to be around 35,000. So if you do 36,000, actually no, that has nothing to do with it. That's like 350 times 100. So it's going to be between 180 and 190. A lot closer to 190. Okay. So if you divide by 190, you get 185. And if you divide by all the numbers between 180 and 190 or try to, they're not divisible. So you don't get any consecutive pair that products to this. Okay. Out of these two numbers, what we just did was make sure it satisfies both conditions. So 181 is our final answer. And make sure you check out my video on the better rated it is, because this is a way using elementary algebra and number 3, which checks out of the probable n which one is the best. Okay, thanks for watching.